Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. The starting material has two alkene-containing side chains on an orthodesubstituted benzene ring bearing an OMe group. One chain is a E hex 2N1 vial group, an internal desubstituted trans alkene, and the other is a 4-pentanol group containing a terminal monosubstituted alkene as well as a ketone carbonyl. Moving on to the next step. Reactivity of MCPBA toward different functional groups. MCPBA is an electrophilic peracid that epoxidizes alkenes. Its reactivity toward alkenes follows the order: more electron-rich, more substituted alkenes react faster than less substituted ones. Additionally, MCPBA can perform Baeyer-Villiger oxidation on ketones, but this is generally slower and requires more forcing conditions than simple alkene epoxidation. Moving on to the next step. The internal trans alkene in the hex 2N1 vial chain is desubstituted and more electron-rich than the terminal alkene in the pentanol chain. Moreover, the terminal alkene of the pentanol chain is electron-poor because it is conjugated with or adjacent to the electron-withdrawing ketone carbonyl, making it less reactive toward electrophilic epoxidation. Therefore, under these conditions, 75% yield, presumably one equivalent of MCPBA, the more electron-rich internal alkene of the hex 2N1 vial chain is selectively epoxidized. And for the final step, option B shows the internal double bond of the hex 2N1 vial chain converted to an epoxide, while the terminal alkene of the pentanol chain remains intact. This is consistent with selective epoxidation of the more electron-rich, more substituted alkene. Option A shows epoxidation of the terminal alkene on the keto chain, less reactive, electron-poor, while leaving the internal alkene intact, opposite to expected selectivity. Option C shows a Baeyer-Villiger type rearrangement of the ketone, which would require different more forcing conditions, and MCPBA would preferentially epoxidize the electron-rich alkene first. Option D is eliminated because option B correctly describes the product. Therefore, the correct answer is B. Therefore, the correct answer is option B.